Hello, it's Professor Todd again, and today we will look at converting one digital number into another. Okay, let's do binary to hexadecimal. Remember the base for binary. This is base number 2, and for hexadecimal, it's base 16. Okay, so binary to hexadecimal. Okay, so let's put a line here. All right, so let's do 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and oh boy, 2 to the 7. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 bits of binary. Okay, and let's just go make a little table like there. I can get rid of, that's better. Okay, now let's write the weighted values. 1, 2, 4, 8, 16, 32, 64, and 128. So that's moving from the least significant bit, which is always on the right, to the most significant bit, which is always on the left. Okay, let's bring it down a little more like that. Okay, so let's put in just a random binary number. 1, 0, 1, 1, 1, 1, 0, something like that, okay? So we can say then that 1 hexadecimal digit uses or corresponds to, whichever you like, uses 4, exactly 4 binary digits. Okay, so 4 binary digits can be represented as 1 hexadecimal. Okay, I need a highlighter. So starting from the right, I'm just going to count over 4. And then I'll just to extend that down. Okay, so we have 4 digits here. And we have 4 digits there. Okay, so the way to do this is to say, okay, so this number here, if you add up the weighted values, you have 8 plus 4 is 12 plus 2 is 14. Don't add the 0 because there's a 0 in that. Don't add the 1 because there's a 0 in that position. So that's 8 plus 4 plus 2. So that's 12. That's 14. And 14 in decimal corresponds in hexadecimal to the letter E. Okay. Now we come over to the other side. So we have, so These weighted numbers are the entire 8-bit values of the entire 8-bit sequence, but in hexadecimal you're only working in four digits on their own. So this is going to be 1, 2, 4, and 8. So we're going to add 8 plus 2 is 10 plus 1 is 11, and 11 decimal is equivalent to B hexadecimal. So the final result would be B, E, and then we'll add the subscript 16 just to be clear that it is hexadecimal. Okay. Let's do another one. Okay. 0, 1, 1, 1, and then 1, 1, 0, 1. Okay. So add up the weighted numbers. So this is going to be 1 plus 4. So this is 2, and there's a 0 there, so we're not going to use it. Plus 8. So 8 plus 4 is 12. Plus 1 is 13 decimal. And that's equivalent to, so in hexadecimal, A is 10, B, C, E. Okay, just like that. So 13 is going to correspond to D. And then over here, 1, 2, 4, the 8, there's a 0, so we're not going to use it. So it's 4 plus 2, which is 6, plus 1 is 7. So that equals 7 hexadecimal. So that is 7D, 7D base 16. Yeah. Okay, so just to summarize, so in decimal, which is base 10, and hexadecimal, which is base 16. So we have 0, 0, 1, 1, 9, 9, and then 10 to 15 corresponds A to F. Okay? So let's do hexadecimal into binary. Okay, so let's do 8A hexadecimal. Okay, so again, just break each one up, put a line there, because each hexadecimal digit will correspond to 4 bits of binary. So 8 is going to be 1, 0, 0, 0. Put a line. And then A is 10. So it's 8, 0, 1, 0. So if you add up the weighted positions of each of these, then so this will be 10 in decimal and 8, and of course that corresponds to A. All right, so that's all you have to do. Let's do another one. Let's do C A 2 hexadecimal into binary. Again, each to start each digit and just represent each digit with 4 bits of binary. It doesn't matter if you start in the left or the right, so I'll start in the right this time. So 2 is going to be positionally 0, 0, 1, 0. A is going to be 10, so it's going to be 8. C will be 10, 11, 12. So this will be 8 plus 4. Okay, so that's going to be there, and that's going to be there, and that's going to be there, and that's going to be there. So this is C, A, and 2. So the final answer is 1, 1. And I'll just add the subscript 2 to clarify that it's binary. Okay, so looks okay. Okay, binary into octal. Octal is base 8. And octal digits uses 3 bits of binary. So do exactly what you did with the hexadecimal, but it's only 3 bits now. Okay, so we're doing binary into octal. Okay, so in octal, then in decimal, okay, and then, so here's how the counting works. All right, so this is going to be 0, 1, 2, 3, 4 to 7. And then in octal, it's 0, 1, 2. So all the numbers match. So to be clear, we should add little subscripts in there just to note if we're doing which base we're looking at. Okay, so let's do binary again. I'm just going to make up some numbers. 1, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1. Just kind of random, okay? All right. Start on the right and break up into, or the left. Start on the right and break up into three digits. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. So whether you're dealing with hexadecimal or octal, hexadecimal needs exactly 4 bits of binary, no more, no less. Octal needs exactly 3 bits of binary, no more, no less. And I just realized so we're going to have to have an extra one. So let's just get rid of that. So I don't have room on my screen to add anymore. Okay, sorry. Okay. All right. Okay, so then here's what we do, right? Okay, so then we just take each 3 bits. So this is going to be 1, 2, 4. So this is going to be 5, 5, 4, and 5. And then into octal is going to be base 8. Okay, let's do another one. 1, 1, 1, 0, 1, 1, 1, 1, 0. We got 1, 2, 3. Okay, all right, that should be okay. Okay, again, these are all base 2. All right, so here we have 7, we have 6, and we have 3, and then this is octal as base 8. Okay, so again, octal counts 0 to 7. There's 8 combinations, including the 0, but the 7 is the maximum count state. And then I think this is the last one. Decimal into octal. Okay. Octal. Decimal to octal. All right. So let's do the number. I don't know. Let's just do 36. 36 decimal. Okay. Right. So write 36 in binary. I don't know. I learned to do this all in the table to do all the conversions. I don't know. I just find it easier. Okay, this is a weighted value of 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32. Okay. So for 36, we need a 1 there. So that's 32. We just need 4 more. A 1 there. 0, 0, 0, 0. So intermediate, maybe I should stem this down. Intermediate, then we convert the decimal number into binary just by summing the weighted values. And then you simply go then and go put a line every 3. Okay. And then convert each of those groups of 3. Okay. So this is going to be 4. Right? 1, 2, 4. And then this is going to be 4, just the way it works out. So that would be 44. Okay, so go to decimal, go to binary, and then go to octal. There's methods for convert to hexadecimal by repeated division by 16 and to octal to repeated division by 8. Be honest with you, I can never remember how to do it. I just use the table. It's to me maybe it's a little longer. I don't know. It just seems more easy that way. But anyway, so I guess that's about it, and we'll catch you later. I'm just looking at it. Yeah, looks okay. All right. Cheers. Yeah. Bye bye.